Hi friends, welcome back. In the last episode, we were trying to understand the resolution of vectors and we had resolved the vectors along the two arbitrary directions, say A and B. And then I referred that in the next episode, we will be discussing the resolution of vectors along the three standard lines in the rectangular Cartesian coordinate system, in which we have three coordinate system. The Cartesian coordinate system is x, y, z. Do not worry, in some books you may find x here, y here, g here and differently. Do not worry, x, y, g means x, y, z three axes which are perpendicular to each other and which describe the whole space. This is 3 dimension. So, this describe the whole space. So, no matter in which direction you choose it to be x, you choose it to be y or g. Do not worry, it is same throughout. Simple algebra changes, but for the sake of simplicity, I will be continuing taking x along this direction from east to west, from north to south, I will be south to north, I will be taking y, and then perpendicular to it, I will be taking g axis throughout as long as possible. I will be taking this until unless I speak for it. If I am becoming different, I will be telling it to you one. Now, let us define three unit vectors along x, y and g axes. Here unit vectors means unit vector along x axis means the vector which is along x axis and whose magnitude is unity, means 1, magnitude is unity. So, look at this I vector is this like this. Similarly, I have defined the vector j, means the vector j is means vector along y axis having magnitude plus 1. Similarly, k unit vector, in some books you may find it like this I j cap with the cap. While writing, we write the unit vectors with the caps notations. It is uniformly given everywhere. Do not worry, both are same. Here I have just used capital signs. Do not worry. So, this is how we define unit vectors along x axis, y axis and z axis. Again the same thing is defined in this thing. So, if I were to define a point P here in space, suppose if this room has one corner or one bottom corner is its origin, then the three axes, three sides around it will be x, y, z in whatsoever order you take it, do not worry, that is not a problem. And in between, if you define a point P, what will be the coordinate of this? So, according to the coordinate geometry, you already know that its coordinates will be x, y and g. You write x, y and g, you write it, true. Now, if you take a box of it, if you take a box of it, see these unit vectors can further be defined it as I, j, k. If you join all those, you will get a cube of unit dimension. You will get a cube of unit dimension. Now, look at this I, j, k. Do not worry about this notation. Here I have used caps. Do not worry whether you use a cap or not, same thing. Modulus, these two long bars tells you the modulus. Its modulus is 1, its modulus is 1, its modulus is 1. When you take the modulus of any vector quantity, it means it has lost its directional properties. So, it is always 1. Now, if a vector A, suppose if I write a vector A such that its along x axis, vector A along x axis and its unit is 2, its length is 2I, its magnitude is 2. So, I along x axis, so unit vector is I. Now, I and I 2. So, this vector A is nothing but simply 2I, clear, and in general lambda I, in general it is lambda I. In this particular case, lambda is equal to 2 and therefore, the magnitude of vector A is 2. Now, I can can I write this vector? How can I write this vector is A is equal to modulus of A now in terms of its unit vectors I. Now, remember we have already discussed about the multiplication of a real number with a vector quantity, with a real multiplication of a vector with a real number. Similar properties I have used here, right. In general, here I have used I. In general, I, j, whether it is I, j or k, combinedly we can write it n or n, unit vector n along any direction. Now, with this we can choose. Remember friends, the choice of axis is always ours. This is a man-made phenomena. Choice of axis is always ours. So, we can take any axis to be x axis and perpendicular to it in a particular plane is y axis, and perpendicular to this plane in which contains x and y we have z axis, g axis. The choice of axis is always ours. Okay. So, we can take x axis along any direction. So, in a particular plane a direction perpendicular to x axis is y axis and a direction perpendicular to this plane is z axis. Okay. So, this to x, y, g can be rotated, can be changed, anything you can do. The only thing is the Cartesian coordinate system say that x, y and g axis are perpendicular to each other, that is all. Now, x, there are many faces to it, many surfaces to it. X, y gives you one plane, y, z gives you another plane, and still x, z will give you another third plane. Okay. Well, so n is a unit vector along any arbitrary vector A. This is general picture. So, now if I say again this is my basic notation which we have used in the last slide also. Now, if I have a vector A here, now if its resolution A1, its effect on A1 as in do in the Cartesian coordinate system, as you give the coordinates of any point x y. Similarly, you write x y point as x y, and then similarly I can write A1 and A2 here. So, it has the vector along x axis is A1. Okay. So, this vector will be A1I. Okay. This vector will be my A1I plus A2j. Okay, like this. So, this is how, and now this vector is making an angle. So, here if you see a vector A who has components A1 along x axis and component A2 along y axis. Now, here, so along x axis the vector will be AXI, this is the resolution of vector A along x axis, AXI AYJ. So, as a result I can write vector A as AXI plus AYJ. Now, I have been able to resolve this vector A along x axis and along y axis. Similarly, the angle between these two is theta. Now, how to find out these values? I will do it in the next slide. Now, let us see it little differently in all the 4 quadrants. Remember, this is the quadrant. I am taking a plane x y plane. So, this is x, this is y, this is my first quadrant, this is my second quadrant, this is my third quadrant, and this is my fourth quadrant. This is how you always take it. You are used to doing all these things. So, in this quadrant x is positive, y is positive. In this quadrant x is negative, y is positive. In this quadrant x is negative as well as y is negative, both are negative. Here x is positive, but y is negative. So, let us see if a vector A looks like this, if vector A is this, then its resolutions are like this. So, A y is greater than 0, A x is greater than 0, and if this A vector A lies in second quadrant like this, then this angle theta. Remember friends, this angle theta is a vector quantity, you will turn it. So, because it can be clockwise or it may be anti-clockwise, and so remember here it is anti-clockwise, here it is clockwise. So, remember the angle is as far as possible in general is taken from x axis. This is a convention. However, there is nothing wrong if we take along y axis, then we have to say it specifically, as we say in the case of rains etc., when we take the relative speeds etc. You know, you have done it in class last chapter too. So, but in general we try to take it with the x axis and then clockwise and anti-clockwise. So, in this case it is the anti-clockwise, and in this case it is clockwise. Third quadrant is this, and then this is the fourth quadrant. This is just a picture to see it how it works and how the vectors look like when they are resolved in different directions, how the vectors look like, I mean represents how the what happens to their magnitudes when they are resolved in different coordinate systems, different quadrants. Okay. Now, we have learned the resolution of vectors. I have done it last time also. A is equal to a lambda I have written it lambda A plus mu B. the same way I can write is A vector is equal to A x I. What is A x? The resolution, magnitude of the resolution along x axis. Similarly, A y is the magnitude of the resolution of vector A along y axis. How do we know I and j are the unit vectors along x and y axis respectively? And remember, these are just numbers. These are just real numbers, because I have written it in italics. This is just a notation. This is the convention of writing it in the notations, that these italics are just real numbers, do not worry. So, here by simple trigonometric functions, I am sure that you have seen the trigonometric functions. Simple, look at this angle, look at this diagram. This is vector A, this is angle theta. What is cos theta? Hypotenuse divided by base, right. So, cos theta is equal to Ax divided by A. So, Ax is nothing but my simply A cos theta. Shall I repeat it? Fine. What is cos theta in this diagram? Base divided by hypotenuse. Base divided by hypotenuse means Ax divided by A, means Ax is equal to A cos theta, right. Similarly, what is sin theta? Ay divided by A. So, A is equal to my Ay is equal to my A sin theta. Very simple. Simple trigonometric relation, simple trigonometric relation. So, this is how you can resolve, you are being able to resolve it. Now, look at the interesting mathematics of it. Ax square plus Ay square is nothing but A square cos square theta plus A square sin square theta. Cos square theta plus sin square theta is your unity, is equal to 1, we know it by simple trigonometric relationship. So, this is equal to A square, or A is equal to A under root Ax square plus Ay square. Now, let us see what is the value of tan theta. How do we find out the angle of theta? If you do it in the same diagram, the tan theta is equal to, this is Ax and this is my Ay, this is my Ay. So, my tan theta is equal to perpendicular divided by base. So, Ay by Ax, or theta is equal to nothing but tan inverse Ay Ax. This is how you can define it. Now, let us do it in 3 dimension case similarly. Now, in the case of 3 dimension, you see this is a vector. This vector A is a vector. Now, this vector has a resolution here in x y plane. Now, if this vector x, z and y, right, I will have a better diagram to show you little later. Let you first try to comprehend it. So, the situation is that x axis, y axis and vector A is there. Now, this vector A makes an angle alpha with x axis and angle beta with y axis and angle gamma with z axis, right. Now, if I try to resolve them out, I will find Ax is equal to A cos alpha, Ay is equal to A cos beta, Az is equal to A cos gamma, and in general I can write A is equal to Axi plus Ayj plus Azk as I did last time. And if you do all these things, vector algebra which I did last time in the case of plane, you will get A is equal to the magnitude of A is equal to nothing but Ax square plus Ay square plus Az square. So, a positive vector R can be expressed as R is equal to Xi plus Yj plus Zk. What are x, y, z? These are the components along x axis, y axis, z axis respectively. Now, needless to say that I, j, k are the unit vectors along x, y, z directions respectively. So, this is how you can resolve the vectors. Now, let us do an exercise. Now, let us do an exercise. Write down a unit vector in x y plane making an angle of 30 degree with the plus x axis. This is vector A, this is angle 30. Now, we have A is equal to xi plus yz plus zk. Now, we know we have to do it in xy plane. So, z is equal to 0, directly z is equal to 0. So, I can write xi plus yz plus equal to 0 k. So, I can draw this line diagram like this, having x y axis and 30 degree angle. So, this will give me a unit vector of this question. Next, now let us do it analytically. Let us do it analytically. Let us take 2 vectors A and B like this. We can write it like this very easily, or we can do the simple algebra like this, which is analogous to simple algebra. So, the total R x, so this I can write as a R as a component, the resultant of A plus B as a component of R x I plus R y j, where R x is the component of R, where resultant vector R along x axis, a component of R along y axis. So, now the addition of the two vectors A and B, R is equal to A x plus B, R is equal to A plus B, can be rewritten as R x I plus R y j, where R x and R y are these, and you can very easily comprehend through this diagram here. So, where the two vectors A and B are shown and having different angles. So, these angles, and now you can, I am leaving it to you children that you have to represent the vector R here. What is the vector R here? So, A plus B, what will be the value of A plus B? You have to comprehend it and you have to give it to me. I am not doing it here for your case, you have to do it for, this is a hint here that you have to do it the law of parallelogram, not the triangular law, because both vectors are applied at the same time at this point. Now, after having seen that how the vectors are added, let us see a realistic situation where these are used. The question, I am doing this question again, I will not be dealing this question in great detail at this time, but you should do it. You should understand this question. This question is given in your textbook too. The rain is falling vertically. Rain is falling vertically with a speed of 35 meter per second. Okay, with a speed of 35 meter per second. Now, these are the velocity vectors. Now, suddenly the wind starts blowing along a direction from east to west. So, this velocity vector with a speed of 12 meter per second. See, when I am saying speed, remember my words, speed of 12 meters per second, this is scalar, but when I am adding the direction to it from east to west, then it becomes a vector quantity, right. Now, in which direction should a boy waiting a bus stop hold the umbrella? Okay. So, now you have to add, now the child is standing. So, now you have to add the two vectors to find out the resultant vector, and then you can find out that the 19 degree, this problem is solved in your textbook. So, I am not discussing in detail. So, you can see that 19 degree at the child should hold the umbrella at 19 degrees like this. Well, now, as I said that I will be telling you resolution of vectors in 3-dimensional space. This is the diagram. Suppose these are by x axis, or you recall that in the beginning also I said it, repeated it sometimes, that the choice of axis is always yours. Now, I have taken a different axis system, x axis in this direction, y in this, z in this, all are perpendicular to each other, Now, this is the vector shown by green arrow. Now, its projection in xy plane is this. Okay. Now, suppose this vector, this angle is theta and its magnitude is a. So, then this will be my a cos theta, and this blue will be my a sin theta. And now, this vector has come here. Now, if this angle is alpha, so the vector angle, the component along y axis will be my a cos theta cos alpha, and similarly here. This is the type of exercise we will keep on doing again and again. Ponder about it a little more, about these resolutions, and you can solve these problems very easily. This is a very good diagram to have it. In fact, this diagram itself shows the resolution of vectors in 3-dimensional space. Now, in 3-dimensional space, I am coming further high. Now, if we say a vector A, B, two vectors, these are having 3-dimensional space I, j, k, having components a x, a y, a z, b x, b y, b z along x, y, z directions. Now, if the resultant of this, the total resultant is t, let us say a plus b, then we can do this calculation and we can find out a x. What is t x? 3 components, t is equal to t x, t y, t z, where t x, t y, t z are numbers. How these numbers can be given? T x is equal to nothing but a x plus b x, t y is equal to a y plus b y, and t z is equal to a z plus b z. Now, this is again diagram. Now, you see vector. A vector is drawn here in 3-dimensional space. Now, again you see I have drawn another picture, just for your convenience, coordinate system. I am playing with the coordinate system just to express it that this is our choice. I can do it with the way I want to do it. No problem. Nothing stops me. I can do it. the way I have now taken f1, say x axis is in direction, y direction in this y in this direction and z in this direction, all are perpendicular to each other. Okay. This is my choice. I have used my choice. I have used my choice to redraw this diagram. Please comprehend it. Now, I take, now let us take 3 vectors. Let us do some exercise. 3 vectors, some practice exercise. There are 3 vectors. 3 vectors are can be written like this. Okay. Now, total S. This is not difficult to comprehend. You can do it by simple algebra. S x I, S y j, where S x, x, y and g are written like this. So, and the magnitude of S, see, remember here it is minus A s is equal to A plus B minus C. So, this is how you can do the algebra, vector algebra, addition and subtraction of vectors, more than 2 vectors. There may be n number of vectors, one after the other. There may be n number of vectors after the other. So, this is how you can calculate the whole mathematics of it. Now, position vector and displacement. Now, let me come out of this algebra. Vector algebra is complete. Now, let us come to the physics side, pure physics. So, some physics I have already discussed, but let us be pure in physics. Now, this a position vector, this is a point O is here. Now, let us talk about a plane. I have been able to express you that how you can explain the 2-dimensional theory to 3-dimensional theory, how you can extend. In place of I and j, you can take I, j and k 3 together. So, now on I will construct myself to 2-dimensional theory, 2 dimension only. So, R is equal to a vector, position vector is given by x I plus y j. Position vector means this is the point where the point something is object is there. So, this with respect to this origin, origin of the coordinate system, chosen coordinate system O, the position vector of P is R given by x I plus y j. What are x and y? Are the components along x axis and y axis together. Now, so the position, now let us say this point shifts, this particle shifts from point P to point P dash. This its coordinate is x y, its coordinates are x dash, y dash, shifts and at a time delta t. Let us say this was at time t 1, this is at time t 2. So, in a time delta t is equal to t 2 minus t 1. Now, from position vector r to another vector r dash, how it happens? Yes, look, the particle is moving at time t is equal to t 1, this r is the position vector, at time t 2 is equal to, this is the position vector, p dash is the position vector. So, delta r, this is the result, delta r is equal to r dash minus r, that we can do simple mathematics, triangular law of mathematics, etc. And then you can find out delta x is equal to nothing but delta x dash minus x, and y delta y is equal to y dash minus y, simply mathematics. So, velocity can be given as displacement by time. What is the displacement? Delta x plus delta y, v is equal to delta r by delta t is equal to I delta x plus j delta y delta t. So, v is equal to nothing v x I plus v y j, and we can find out different components like this v x dash. These are the magnitudes, this is the vector quantity, and these are the magnitudes of components along x axis and y axis respectively. So, this is how you can find out. You probably this type of graphs are familiar to you, and you can do it very easily. Now, instantaneous velocity. Now, let us take the instantaneous velocity. What happens in the case of instantaneous velocity? The limiting value of average velocity as time, interval delta t comes down to 0, it limits to 0, it becomes negligibly small, very small. Now, let us see in this diagram, as this changes, as this point delta t changes. So, delta r will also be 0, delta r will also be, as delta t tends to 0, delta r also tends to 0, means delta r means the change in the 2 position vectors, it also tends to be 0. So, now in this case you will see that the direction of v is delta r 3, and which is nothing but the tangent at that particular point. Suppose this is the motion. Now, at this is first point and this is second point. So, as delta t decreases, so this delta r will also keep on decreasing and will also become like a point if delta t becomes negligibly small. So, this delta r, so this point, this division, this difference would appear like a point say here like that. So, now if you draw this vector, so it will become a tangent at this point. So, velocity along a path is nothing, is the direction of velocity is nothing but the tangent at that particular point v. So, this you understood that the velocity vector, instantaneous velocity vector is always a tangent onto the curve at that particular point, and if the velocity is uniform. So, this velocity vector will again be in the same path in which the particle is moving. However, it is not always necessary for the case of the average velocity. Instantaneous velocity, which is commonly said to be the velocity of the object. So, this is how we can understand the graphically the meaning of instantaneous velocity. So, the velocity is nothing but dr by dt, the rate of change of position vector with respect to time, or we can rewrite it in the components form as like this. I need not to reiterate on this you can comprehend very easily, I am sure. So, or I can rewrite it as a opinion is as v, thus I can write v is equal to I dx by dt plus j dy by dt is equal to, if it is a case of 3 dimension, then another vector will, another component will also come k dz by dt, do not worry about that. So, this becomes v x I plus v y j. So, where v x and v y are having the simpler values, and the magnitude of this velocity can be given as under root v x square plus v y square. You can do it very simply with the simple logics which I have already iterated, that you can get this simple and this, and the direction you can get it by v y by v x is equal to theta, and therefore, this direction theta can be iterated as tan inverse v y by v x, and probably this is the reason why you say the tangent, how the word tangent is coming for the direction of the velocity at a particular time. When delta t decreases to 0, the velocity becomes tangent at that particular point. So, because the direction is given by the tangent of the angle tan inverse. Remember the simple coordinate geometry, friends, and you can comprehend it very easily. I am becoming a little faster because purposely knowing it that I have done the enough formulation fundamental basics of it very slowly, very coolly. I hope that you can do it very nicely, very nicely. So, in the next episode we will take some particular examples of this motion like projectile motion and the uniform circular motion. These are two interesting cases, and these we will keep we will move ahead towards these applications. We will take some, however, we will take some cases of the relative velocity, etc. Just recap, and then we will move ahead. So, till then please keep on studying it, my dear friends, and then keep on revising it. Then you will be able to comprehend it very easily. I assure you, my dear friends, you revise it at least once or twice, you will be able to comprehend it very nicely. And till then, friends, bye.